So we have this trigonometric function up here, f of x equals 2 sine blah blah blah, a bunch of signs. So the amplitude is the coefficient of the trig function. So the amplitude is 2. The period for sine and cosine is always going to be found by taking 2 pi and dividing it by the absolute value b, so just the positive value of b, where b is this value here. B is pi over 3. So if we do that off to the side, we've got 2 pi divided by this fraction pi over 3. And so we know how to divide a fraction. If you divide by pi over 3, that's the same thing as flipping pi over 3 and then multiplying. So if you flip and multiply and cross cancel, you're going to get 6 for the period. Okay? So I plugged in pi over 3 in for b, and I flipped and multiplied because I was dividing a fraction. The equation of the midline is found by, it's just this plus 4 on the outside, because it shifts it 4 units up from the origin. So for sine, the equation of the midline is always just that vertical shift. For cosine, it's a little bit different. You could do your vertical shift, and then cosine will be halfway between the peak and the lowest point of the graph of your function. That's the equation of the midline is, if you have a sinusoidal wave like this, like cosine or sine, the equation of the midline is the y equals value that's exactly halfway through. Phase shift. When it's factored, when x doesn't have a coefficient like it is here, when you factored out that pi over 3, the phase shift is just this minus 4 part. So that's actually 4 units to the right. And what a phase shift means is that, hey, the sine function usually starts at the origin like this. And at phase shift, if you have a minus 4, the minus is kind of reverse of what we usually think. We usually think minus means we go left. That means we go 1, 2, 3, 4 units to the right, and that's where the graph of the function starts. So that's what that minus 4 tells us. The vertical translation is it's 4 units up. Okay, 4 units up. And this is 4 units right. Because the plus 4 makes us go 4 units up. Okay, so that's enough information to give us a sketch of the graph. Usually sine starts at the origin, but we had a phase shift of 4 units to the right, and we had a vertical translation for this of 4 units up. So that's our starting dot. And sine usually starts like this wave. We're just starting the wave up here. Okay, so that's a rough sketch of one period of our graph. The period is 6 units. That means we need to, by the time we come back to the start, by the time we come back to that same y value of 4, we should be back to the beginning of the graph, just about to, before we even repeat ourselves. That's the place where we start repeating ourselves. So if I went 4 units to the right, then I've got 1, I got this at 5, 6, 7, 8, oops, 9, 10 was a little off. It should be 6 units to the right on the x-axis. And then the amplitude of 2 just means we go 2 units up and 2 units down from the midline. So my graph should actually dip a little bit lower to make sure we're at 2 on the y for the lowest part, and then 6 as the highest part. Okay, I think we got everything. The midline is just y equals 4, this horizontal line. So that's a sketch of the graph. For x in the interval 0 to p, where I think they define, I've cut that out, but I think p is the first period of the function. From 0 to p, the maximum y value is, so if we were to sketch this going backwards, it dips down to positive 2. And now it's supposed to repeat itself every 6 units. So look, 1, 2, 3, 4, 5, 6. It should be back to the start here at x equals negative 2. So I've got to come up to the peak and then come here. So that's kind of tricky because this is just a rough sketch. Where is the peak? What you could do is, since we know that 6 is the peak, we know y equals 6 is the peak, you could plug in 6 in for f of x and then solve that equation. But at this point in the course, it's kind of a tricky thing to do. So I'm going to show you another option. Later on in the course, we'll have we'll practice trig more, being able to do trig without calculators. But you could go to this website called desmos.com/calculator. Type in the function we have, 2 sine of pi over 3 x minus 4 plus 4. Okay, and that gives us our graph. And then they said from 0 to 6, from 0 to p, where's the location of the peak of the amplitude? And it's at 5.5 on the x-axis. So 5.5 is the x-coordinate of the maximum y value. And the actual maximum y value we already found is 6. Okay, so a big goal of pre-calculus is to know how to describe roughly what the function looks like without having to rely on other sources like calculators. So that's why this skill is important. If you needed to explain your work on this, you could say we could substitute y equals 6 into the function and solve, and you should get x equals 5.5. Because calculators usually give us just the first period of a trig function anyway. For the x interval, same type of thing, the minimum y value. It's somewhere around here, so we can use Desmos to get that exact value. It occurs at x equals 2.5, and that minimum y value is 2.